Today we will talk about chain rule for differentiation. It says, suppose y is a function of u. So if u changes, y changes, and u is a function of x. For example, it might be possible y is equal to sine u, and u might be x square. Then what we want to say is y indirectly depends upon x. In this example, essentially we are dealing with y is equal to sine of x square. So if you want to find out how y changes with x instantaneously, then you might want to evaluate dy by dx of this function, for which we don't have any formula. We know differentiation of sine x with respect to x, but we don't know what is the differentiation of sine x square. For that, you can follow chain rule. It says if you want to find dy by dx, where y is a function of u and u is a function of x, then you can simply find how y is changing with u and multiply with how u is changing with x. So this is a very important setup. You might want to remember the order. So it is dy by dx is dy by du into du by dx. You find rate of change of y with respect to u, you find rate of change of u with respect to x, and multiply them to get dy by dx. Using chain rule, let's try to evaluate functions like this. This example, y is equal to sine of x square, where we can set up y is equal to sine u, where u is x square, and apply chain rule. So we can write here dy by du into du by dx, and let's try to evaluate this. Now y as a function of u is sine u, so we can write it here sine u, and u as a function of x is x square. So sine u differentiated with respect to u will be cos u, and x square differentiated with respect to x is 2x. Now you can back substitute u here, so it will be cos of x square into 2x, which will be the answer to the differentiation of y is equal to sine of x square. So dy by dx of sine x square is just cos of x square into 2x. Let's try to do some more example. Suppose we have to find differentiation of sine 2x. So we know the differentiation of sine x with respect to x, but we don't know the differentiation of sine 2x. So what we can do here is, we can use chain rule. We can write, let's say y is equal to sine 2x is equal to, let's say, sine u, where we have substituted u is equal to 2x. Now y is a function of u. You can see y here is a function of u. Y is equal to sine u, and u is a function of x. Then by chain rule, we can apply here dy by dx can be written as dy by du into du by dx. So you can write it here that dy by dx of sine 2x will be equal to dy by du. Dy by du is differentiation of y, which is sine u. So d by du of sine u into d by dx of u. U is 2x. So your answer would be differentiation of sin u is cos u, and differentiation of 2x will be 2. So your final answer would be cos of 2x into 2, or 2 cos 2x. So let's try to repeat these steps for quick calculation here. So we'll have here d by dx of sin 2x can be written as d by dx of d by du of sin u, where u is equal to 2x, into d by dx of 2x. Then d by du of sin u is cos u, and d by dx of 2x is 2. You can be back substituted, and it is equal to 2x then, cos 2x. Let's continue with another example. Suppose we have to find d by dx of under root of x square plus 1. So we don't know any formula to differentiate this. So we can try chain rule, and let's say y is equal to root of x square plus 1. So let's try to substitute y in terms of u. Let's say u equal to x square plus 1. Then y will become under root of u. Now dy by dx by the application of chain rule can be written as dy by du, where you will put y in terms of u, into du by dx. It's pretty straightforward now. Y as a function of u appears here, and you can write it here. Dy by du will be d by du of root u, then du by dx. So you have to substitute u in terms of x, which you can see is here. So you can put substitution d by dx of u. U is x square plus 1, and that will do. So in the next step, we can write it as root u. It is u to the power half. We can apply that formula, x to the power n formula. You get half u raised to the power half minus 1 into differentiation of x square plus 1. So it is differentiation of x square plus differentiation of 1. Differentiation of 1 will give you 0. Differentiation of x square will give you 2x. Now this will become 1 by 2 root u. This will be u to the power minus half taken to the denominator into 2x. So 2 will cancel out. Your answer will be 1 by root u, that you can back substitute. That root u is nothing but y. In terms of x, u is just under root of x square plus 1. Here you can see u is x square plus 1. So root u will be under root of x square plus 1 into x. So let's continue with some more example. Suppose we have y is equal to e to the power of x square, and we have to find dy by dx. Then what you can do is use chain rule. Under the setup that y is equal to e to the power u and u is equal to x square, then chain rule allows you to evaluate this function as dy by dx will be dy by du into du by dx. Dy by du is d by du of e to the power u into d by dx of u in terms of x is x square. Then now you can see e to the power u differentiated with respect to u will be e to the power u, and differentiation of x square will be simply 2x using the formula formula for differentiation of elementary function. Then you can here back substitute u. U is e to the power of u is x square, so you go to the power of x square into 2x. So the answer for e to the power x square would be e to the power of x square into differentiation of x square, which is 2x. Let's take another example. Y is equal to, let's say, let's sin ax plus b, where a and b are constant, and you have to find dy by dx. Then you will write it as d by dx of sin ax plus b. But you know the differentiation of sin x, and you don't know the differentiation of sin ax plus b by differentiation of elementary function. So what you can do here is, again go for chain rule and use the setup y is equal to sin of u, where u is nothing but ax plus b, and the setup for chain rule dy by dx is nothing but dy by du into du by dx. Now you can differentiate y with respect to u, so you have to put y as a function of u, which appears here. You can put here sin u, and then differentiation of u with respect to u, so d by dx of ax plus b. Then sin u differentiation with respect to u will become cos u, and differentiation of ax plus b will give you differentiation of ax plus differentiation of b. B being constant, differentiation of b with respect to x will be 0, and here differentiation of ax will be simply a. So answer would become a cos u, or a cos ax plus b, because u is ax plus b. Now let's try to follow this step and try to do it directly. Then we know that this will become u and this will become sin u. Then we will write it as d by dx of sin u, which will be cos u. You can directly write here differentiation cos u into du by dx, that is d by dx of ax plus b, or you can write it as d by du, or you can write it as cos u is equal to ax plus b into differentiation of ax plus b, which is a, which is same as a cos ax plus b. Let's take another example. Let's suppose we have y is equal to 1 by 4x plus 5. Here we can try putting y is equal to 1 by u, where u is nothing but 4x plus 5, and use the setup for chain rule, which says dy by dx is equal to dy by du into du by dx. Here you can write y as a function of u. Here y as a function of u appears like this and this. So we have d by du of 1 by u into d by dx of u, and u is 4x plus 5 in terms of x. Now this is u to the power minus 1, so the differentiation will be minus 1 u raised to the power minus 1 minus 1, which is minus 1 by u square into d by dx of 4x will give you 4. The answer would be minus 1 by u is 4x plus 5, so 4x plus 5 whole square into 4. This rule can be extended to any number of variables. Suppose y is equal to a function of u, and u is a function of w, and w is a function of x. Then here also you can apply chain rule directly and write dy by dx. As you can see, y indirectly depends upon x, is equal to differentiation of y with respect to u, because y is a function of u, into differentiation of u with respect to w, because u is a function of w, and differentiation of w with respect to x, because w is a function of x. So it can be extended to any number of variables. So for this problem, you can see we can write d by du of sin u into d by dw of u in terms of w, which is d by dw of log w into dw by dx, so d by dx of w, which is x square. So the differentiation will give you cos u, first term, second term will be 1 by w, and third term will be 2x. Let's substitute u and w in terms of x. Final would be log u. U is log w, and w is x square. So you can write it as log of x square cos of that into 1 by w. 1 by w is 1 by x square into 2x